welcome to Ciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. And I got a 9 in my GCSEs and right now I'm doing my A-levels. So how you can participate, viewers, is you can write something in the chat if you have an idea of how to solve it or something like that. So today we're going to be doing an A-level mathematics session about differentiation.
Yeah, that's right. So welcome viewers. I'm Isaac, experienced maths teacher who helps out with the Deciphers in delivering these free maths workshops. And as Cordelia said, today we're looking at differentiation, particularly looking at the product rule, the chain rule and the quotient rule and applying them to some exam questions. So what we'll do first is go through some of the key things you need to know for this part of the chapter. And I think we'll do another session on differentiation because it's quite a broad topic. We'll do another session on differentiation at some point, but in this one we'll go through what we're going to cover today and then get started with some exam questions. So firstly, we're going to talk about differentiating some trig functions and exponentials and log functions. So you need to know the following two results and to be able to prove them. We're not going to go into the proof of them in this session, but we are going to be using some of these results through our working out today. So the first one is that the derivative of sine kx equals k cos kx. So the coefficient of the angle of x we multiply through when we differentiate as well, and sine differentiates to cos. The fact that we've got sine kx equals k cos kx is actually an example of the chain rule, which we'll talk about in more detail. And then the derivative of cos kx is negative k sine kx. Okay, so you need to know them. They're not in the formula book. You need to know those results. But to be fair, if you're doing your revision, you'll use it so often that it'll become second nature to you. Some other results you need to know for exponentials and logarithms is that the derivative of e to the kx is k e to the kx. Again, that fact that we've got that k as a coefficient of x in our power, we times through by that is an example of the chain rule. The derivative of a, so a constant a, to the power of kx is equal to a to the kx multiplied by k ln a. Okay, and you might need to be asked to show that or prove that result in an exam as well. That's something you would need to know. And the derivative of ln x is 1 over x. Okay, really useful one, and that one's really useful when we're doing some integration as well, which we'll do in a few sessions time. So there's three main rules in our differentiation. So this is sort of the year 2, year 13 content A2 stuff. It's the chain rule. So it's a really powerful method to differentiate what's called a composite function. So one function is contained within another. So for example, e to the power of x squared minus 3x plus 1. X squared minus 3x plus 1 itself is a function and it's contained within the function e to the x. So this rule allows us to differentiate seemingly complex expressions. Okay, and the more and more we do the chain rule, hopefully the more you'll be able to do it sort of by sort of second nature, and it becomes a lot more natural, and you'll be able to do it quickly. But the general rule is dy dx is equal to dy du multiplied by du dx, where y is some function of u and u is another function of x. So just a quick example, if we had our e to the x squared minus 3x plus 1, that would be e to the u, where u is equal to x squared minus 3x plus 1. And what we do, we differentiate our two functions separately. So e to the u differentiates to e to the u. So you differentiate with respect to u, and you differentiate with respect to x. The u function, which is 2x minus 3, and then you multiply them together. So dy dx would be e to the u, which is e to the x squared minus 3x plus 1 multiplied by 2x minus 3. Okay, and you can write that in function notation, which you can see there that if y is f of x all to the n, then dy dx is n multiplied by f of x, n minus 1, so sort of normal differentiation, times by the derivative of f of x. So it's like, if it's a good way to think of it is if it's blah to the n, then you do the derivative of blah, whatever blah is, it could be anything, some function, we'll just call it blah, times by the derivative of blah. And we might refer to that sort of throughout this lesson. And another sort of result from the chain rule is that if the equation is not in the form of y equals x, then y equals some function of x, then we can use the fact that dy dx is actually just the reciprocal of dx dy. So we could differentiate with respect to y, and then just find the reciprocal of that function, and that's another way of finding dy dx. So the other two rules that you need to know are the product rule and the quotient rule. So the product rule is used to differentiate the product of two functions. So if the two functions are u and v, and they're both in terms of x, then dy dx, the derivative of y with respect to x, is u dv dx plus v du dx. A more convenient way to write that is u v prime, or v dash, however you want to say it, plus v u prime. Now, Cordelia, in the product rule, does it matter which function is u and which function is v?
No, because uv is the same as vu.
Yeah, brilliant. So in the product rule, it doesn't matter which function you call u and which function you call v. The quotient rule is, this should say if y equals u over v, then dy over dx, so u over v is our quotient means division, dy dx is v dy dx minus u dy dx over v squared, or v u prime minus u v prime all over v squared. Now in the quotient rule, does it matter which one is v and which one's u?
Yeah, because u in v is not the same as v in u.
Yeah, it does matter. And because you're subtracting in the quotient rule and dividing, then neither of those two operations are commutative, so the order does matter.
Yeah.
Okay, whenever you have the quotient rule, you can actually always do it by the product rule. So, for example, if you had x over 2x plus 1 squared, you could treat that as a product, x multiplied by 2x plus 1 to the negative 2. Because the product rule, in a lot of cases, it could be simpler, but not always. And in some cases, the quotient rule is simpler. So it's important that we know both. The product rule and quotient rule lead us to differentiate some of these trig functions. Okay, I think these are the ones that are given to you in the formula book, along with the quotient rule is given to you in the formula book. But the product, if I remember correctly, the product rule isn't, but the quotient rule is. And these trig functions are given to you, and we might be using them today. So the derivative of tan kx is k sec squared kx. So that kx there is like saying tan of blah. We differentiate tan of blah, which integrates to sec squared of blah, but we times through by the derivative of blah, which in this case is kx. So we times through by the derivative of kx, which is k. So that's where that k comes from. It's the chain rule at the front. Okay. At the front of sec squared, the coefficient. And then we have these other three results. The derivative of cosec kx is negative cosec kx cot kx. The derivative of cot kx is negative k cosec squared kx. And the derivative of sec kx is k sec kx tan kx. You do need how to prove any of these. You might be asked how to prove any of these. And it's going to be useful to know how to prove any of these, because if you for some reason forget to look in the formula book and can't remember the derivatives, then just being able to prove them, there's quite a quick, simple proof deriving these. So that's a good. It's important that you do know those. Okay, so let's get started on the questions. So the way it's going to work, Cortelia's going to work through the questions, and I'm going to offer some tips and advice on as we go through where to pick up those marks. Remember, if you have any questions or any other ways to do it, then just drop anything in the chat.
So for the first question, given y is x times 2x plus 1 to the power of 4, show that dy in dx is 2x plus 1 to the power of n times ax plus b, where n, a and b are constants to be found. So I think this is the chain rule, so I think it's the chain rule and the product rule, because to find the derivative of 2x plus 1 to the power of 4, and so then that needs a chain rule, but to multiply, but we need that times x, so then that's the product rule. Right, so if we do x, right, so then the derivative of x is just 1.
So good advice for answering these questions using the product rule and quotient rule, and I'd always advise to do it just so that we make sure we don't slip up and we're showing enough working out, is to make sure that we're making it really explicit which one we're calling u, which one we're calling v, labelling the derivatives correctly, just so we can go, but if we get something that doesn't quite look right, particularly with this question, it's to show that question, we can go back and check our working out nice and clearly, and obviously the examiner will know what we're doing. So product rule, so it doesn't matter which one's u and which one's v, but let's make sure we're saying which one is u and which one's v.
Okay, so then let's say u is that one and v is that one. So then, if we do, why does it keep going down? If we do the derivative of u with respect to x, okay, so then that is so the chain rule is just do okay, so if we remember the chain rule, that is dy in dx is dy in du times du in dx. So then if we apply that there, then okay, so we already got u and u, so du in dx equals to d of, let's say k is 2x plus 1, and we need another function to be,
No, usually that's fine, just k equals 2x plus 1, because then u is k to the 4.
Yep, so then just replace that with, and just say u is k power 4. So that is dk in, du in dk, du in dk times by dk divided by divided by, I think it's dx.
Yeah, that's right. Yeah, the chain rule makes sense, but even though du dx is not a fraction, it behaves similarly to a fraction. Okay, so like you can think of it, even though it's not technically mathematically correct, it's not a fraction, but du dk times by dk dx is like the dk's cancel out and you're left with du over dx. That's essentially what the chain rule is.
Yep, so then that is the same as, so wait, let's just do dv in dx equals 1. So then that is the same as So the derivative of u with respect to k, well that's 4k cubed times y, and then dk and dx, the derivative of k is 2. If we sub in that case, then 4 times 2x plus 1, 2x plus 1 cubed times 2, and that is 8 times 2x plus 1 cubed.
Good.
Okay, so then we just need to use the product rule now. So that's u times derivative of v plus v times the derivative of u. Then so that's u times 1 plus we know what.
Yeah, we know what they all are now, don't we? So we can actually just plug it into the chain rule. The product rule, sorry.
Then we know that u is 2x plus 1 to the power of 4, so 2x plus 1 to the power of 4 times the derivative of v, that's just 1, so just leave it like that. Plus,
good stuff.
And then v times the derivative of u, that is x times, that's 8x times 2x plus 1 cubed.
Brilliant.
So then if we we want it in the form 2x plus 1 to the power of n times ax plus b. So then that's the same as 2x plus, if we factorize 2x plus 1 cubed, then it's 2x plus 1 cubed times 2x plus 1 plus 8x, that is 2x plus 1 cubed times 10x plus 1.
Fantastic. So what are the values of n, a and b?
So n is 3, a is 10, and capital A is 10, and b is equal to 1.
Excellent, brilliant. And you showed you're working out brilliantly there, but I'm just going to say, just for the viewers as well, that sort of what the examiner expects to see, sort of, is all of this, particularly with the bit with the product rule. But for the chain rule, if you have u equals x plus 1 to the power of 4, the method that Cordelia did, he showed it perfectly and it explained it really, really well. But you can just the examiner will give you the marks if you go straight to the derivative of that. Okay, so you can do the chain rule in your head and it will give you full marks if you do a function like that in your head. So a good way to think about it is blah to the power of 4, so where the blah is 2x plus 1. So you're going to differentiate that and get 4 times blah cubed and multiplied by the derivative of blah, so multiplied by 2. So just going straight to the answer for that will get you the full marks. So you did really well today, but yeah, you could have, an examiner would give you the marks for just going from u to the derivative.
Yep. Then let's go to the next question.
Next question. So that was a nice warm up. They get a bit harder now.
So given that y is 3 sine theta divided by 2 sine theta plus 2 cos theta shows that dy and d theta is a in 1 plus sine of 2 theta, where a is a rational constant to be found. And both of them are between minus pi and 4 to 3 pi and 4. So,
Good.
let's do y is 3 sine theta in 2 sine theta plus 2 cos theta. So then, if we use the quotient rule, then it is u is 3 sine of theta. V is 2 sine theta plus 2 cos theta.
Good. Yeah, and this is definitely one of those cases where you can do it with the product rule, but the quotient rule is definitely easier. I think with some of the polynomial ones where you have a quotient where you've got a polynomial in the numerator and denominator, then maybe the product rule is easier. But because we've got those trig functions in there, it's definitely easier to use the quotient rule.
Yep. Then it's u times the derivative of v minus v times derivative of u divided by, I think it's v squared.
It is v squared, but your numerator is not right. So it's vu prime minus u prime. Remember, you are given that one in the formula book in your exam, so do always double check it if you're in an exam. But yeah, it's a trick. It's easy to get it mixed up because normally u comes first, but yeah, in this case it's vu prime minus uv prime.
Yep. Then that, and then that is the same as v 2 sine of theta plus 2 cos theta that times, I think we need to zoom out a bit.
Yeah, maybe do it underneath the question. Probably be better. You don't want to zoom out too much because people might want to still see the question.
About that much, I think. So then it's that, and then that times then the derivative of u is cos of theta minus sine of theta times the derivative of v, which is the derivative of which is 2 cos theta minus 2 sine theta.
Yeah, minus 2 sine theta. Yeah, well done. Okay, I've just written the u prime and v prime out just in the working out. It's always good to do that because that will pick you up. Working out marks is differentiating either the numerator or denominator. That could get you working out marks. It's good to show it.
Yep. So times by minus sine theta times 2 cos theta minus 2 sine theta. Okay, and then divided by 2 sine of theta plus 2 cos.
Oh, I've just spotted an error from the question. I wonder if anyone in the chat could spot it. Maybe, but if not, see if you can.
Okay. Derivative of, so it's v times the derivative of u. Okay, let's have a look at the notes.
It was quite early on the mistake you made.
Wait a second. Just gonna have a look at that again. 2 sine 2 cos theta. Sine theta. Oh, u is 3 sine theta, not sine theta.
It is. Yeah, so u prime is 3 theta as well.
Yep. 3. Okay, so
Let me just write down here what you've done in line so we can see it a bit clearly. So you've done 2 sine theta plus 2 cos theta, which is v, times by u prime, which is multiplying by 3 theta. And you're taking away u prime, u, which is 3 cos theta, multiplied by v prime, which is 2 theta minus 2 sin theta. Just so we can get it all on one bit of working, and you're divided by v squared, which you've done correctly at v. 2 sin theta plus 2 cos theta, all squared.
okay, then the question says that we have to end up with if something is divided by 1 plus sine of 2 theta. So I think there might be something about a double angle thing going on. It's
Yeah, well done. So spotting that, the fact that you might use the double angle formula. I'm not sure about the double angle formula. One of our previous videos, we did it recently.
So then that is the same. Let's square the bottom bit. It's 2 sine theta plus 2.
Maybe just did on them as well in one step.
Do what?
So you said you're gonna expand the denominator, maybe expand the numerator as well,
Okay.
because there might be some simplifying that's going to come out of this.
So 6 sine theta plus 6 cos of theta minus 6
Oh, are you sure that's right? Double check that.
cos squared, and that's cos squared, and that's sine cos of theta. 6 squared sine theta. Okay, so then minus 6 cos squared of theta plus 6 cos theta sine theta that
Good.
divided by 4 sine squared of theta plus 8 sine theta cos theta
Great.
plus 4 cos squared theta. So then that is, and that is, and that simplifies to make 12 sine theta cos theta divided by.
Good. Just cancel out. Yeah, spot on.
By actually that simplifies to, and then that makes actually 3 over sine squared theta plus 2 sine theta cos theta plus 4, no, not 4, just cos squared theta. Right, so then, so I think, so sine squared plus cos squared, that's 1. So that's the same as 3 sine of theta cos theta divided by 2 sine 2 sine theta cos theta. I think that's
What about the sine squared plus cos squared?
I think that sums to 1, then you can. Oh yeah.
Does sum to 1, but you haven't added one. I haven't added one.
And that is. So it is. It's 3. So then I think 2. Oops. 1 second. Isn't working. Okay, there we go. That is. That's. I'm pretty sure 2 sine theta cos theta. That's sine of 2 theta. So that is 3 sine theta cos of theta.
Oh, Cordelia, I've made a mistake. When I copied your working out, this is my fault. Here, I've put u prime in there, not u.
Okay.
It should be 3 sine theta. That is my fault. I do apologise.
So instead of cos.
And the reason I knew that we'd made a mistake is I was seeing that it wasn't cancelling down to AO with a constant on the top. So because we've shown our working out well, I was able to track back to find out where, and because I'd written down, well, you wrote down what U is and I wrote down what U prime was, I could see the mistake quite quickly. So shows the importance of showing you working out.
Then it's plus 6 sine squared theta. And then 6 cos theta plus 6 cos squared theta plus 6 sine squared theta. Now that is just, whoopsies. Then that is just 6.
6, yeah. And you need your 4 sine squared on the denominator. Because you divide by 4, didn't you? But you can't divide by 4 yet. So keep it at 6 and put your 4, 8 and 4 back in on the denominator.
Yep, then 4, 8 and 4.
Yeah.
So then it is...
Maybe if I'm just going to rub this bit out and then you can do the next bit. There you go.
Next then that is... So then sine squared plus cos squared is 1, so then that's 6 divided by 8 sine theta cos theta plus 4
Good.
cos of theta plus 4.
Yeah, so 6 over 8 sine theta cos theta plus 4. Yeah.
So then that is the same as so 2 sine theta cos theta is sine of 2 theta, so 6 in 4 sine 2 theta.
Brilliant. So the double angle point, I'm just going to make a note of it. So sine theta, 2 sine theta cos theta is identical to sine 2 theta. That's the result that we've used for that last bit working out. Okay, so then
that is
3
over 2 divided by sine of 2 theta plus 1.
Fantastic. So A is
3 over 2.
Fantastic. Good stuff.
We have solved the problem again. So then now for question 3. It's not working. There we go.
So question 3. So we've got a graph that shows, figure 5 shows a sketch of the curve y equals f of x, where f of x is 4 sine 2x over e to the root 2x minus 1, has a maximum point at P and a minimum point at Q, which are both shown in the diagram. Show that the x-coordinate of P and Q are solutions to the equation tan equal to. And then part B is a graph translations question, but we're more interested in part A, but we'll do part B as well.
Next then for part A, show that the so then it's And I think we have to find the maximum turning point and So I think we have to find the maximum turning point and the minimum turning point. Then
Yeah. We don't actually need to find them. We just need to get to a point where we know that x is a solution to that particular equation.
Yep. Then find. So for the so to find turning points, then to find turning points we need to do the derivative equals 0. So then
Yeah.
Then we have to find the derivative of 4 sine 2x divided by each power of root of each power of root 2 times x plus 1. X root 2 plus 1 would be. Then and x is between 0 and pi, and after that what we do is we can use the quotient rule. So
Yeah.
u is
I'd go quotient rule here as well. I'd say with this one it's probably as easy to use the product rule as the quotient rule, but it's not necessarily easier to use the product rule. But it's compared to the last question, it's one where you could probably use either. Where the last question is definitely easier to use the quotient rule.
Yep. Then v is each power of x root 2 plus 1. Then we have to find the derivative of u and v. So du and dx is equal to, we'll call it, wait just 1 second, call it u dash, that is negative a, is it? I think cos of 2x.
Well, it's not negative. Sign differentiates to positive cos.
Next, then u derivative is that. So the derivative of v, well, that is so then we have to use the quotient rule, the chain rule, and derivative of
this is another one similar. We used the chain rule just then to do u prime without showing all your working out. Maybe this is another one where you could just explain it and think of it as e to the blah.
Yep, and that is okay. So that's yes, it is. That's root 2 times e to the power of x root 2 plus 1.
Yeah, that's it. It's as easy as that, yeah. Because it's e to the blah, so blah differentiates blah to root 2x or x root 2 plus 1. So that just differentiates to root 2, and then e to the blah just differentiates to e to the blah.
Yep, so then, whoopsies, and I think v times by the derivative of u minus u times by derivative of v divided by v squared. That is it's 8 cos 2x
Oh, just the question. I just noticed. I just zoomed in on the question. It's root 2x minus 1, not plus 1, which we've done throughout the question. It doesn't affect any of the work out so far.
right?
It should just be minus 1.
And it's minus 1, that is minus 1. Then that's 8 cos of 2x times by the derivative of u. Times by v. That's e to the power of x root 2 minus 1. And then that should be minus 1 too.
Good. 8 cos 2x e to the root 2x minus 1. Yeah, spot on. Take away
Minus u, that's 4 sine 2x times by the derivative of v, which is root 2 times e to the power of x root 2 minus 1.
good stuff.
Root 2 e to the power of root 2 minus 1. Next, then we can do that divided by e to the power of 2x root 2 minus 2, and that is
Yeah. So you squared it, so you doubled the power. Yeah, good. Okay, so yeah, that's spot on. That's the derivative. We don't need to do anything else with it just yet. We're gonna use that now to find the show that the turning points solve tan 2x equals root 2. So, what did you say about turning points?
the derivative equals 0.
Good. Yeah, turning points are where the gradient is 0. The derivative is our gradient function, so we make that equal to 0.
Right, so then 8 cos of 2x times by e to the power of x root 2 minus 1. That minus 4 sine x
And 2x.
sine 2x times root 2 times e to the power of x root 2 minus 1. And that divided by e to the power of 2x root 2 minus 2, and that equals 0. Then, so I guess that means 8 cos of 2x times e to the power of x root 2 minus 1 is 4 sine 2x. That's why root of 2 e to the power of x root 2 minus 1. So then that is...
Yeah.
Right, so then I think that means we can... So we want tan of 2x is root 2. So then we can, to do that, we can divide the expressions to get so a half of 10x is 10 of x times by
2x shouldn't it be?
2.
So tell us what you're dividing by again.
We're dividing 4 sine 2x times root 2 e to the power of x root 2 minus 1 by 8 cos of 2x times e to the power of x root 2 minus 1.
Yeah.
Then,
So that, yeah, good. So that will equal what? You missed out the left hand side.
yeah, so then that is 1.
Good stuff.
And then the tan of 2x equals 2. I got 2 root 2 instead of root 2.
You sure? So you've got a half, divided by a half, times by 2, but you're not going to times by root 2, you're going
I'm going to divide by root 2. I think
to, so it's 2 in root 2.
2 divided by root 2, and then that is root 2. Yay!
Good stuff.
Right, now to the challenge question. Right.
Okay. Well, we've got part B there.
What part B? What part B? I can't see a part B.
For the previous question.
Oh yeah. Okay, so then
Although maybe we'll leave part B because it's not a differentiation question. It's graph transformations. So we'll leave that because we'll want to fit in the challenge question instead.
So we have to show that d squared, so y is ln of 1 plus sine x, where sine x is not minus 1, otherwise it would be ln of 0 and then that's undefined. So we have to show clearly that the second derivative is a function of y, where that's a function to be found. Okay, so we have to find the derivative dy and dx. Right, so we have to use the chain rule, and so the derivative of 1 plus sine x is cos x, and the derivative of ln is 1 divided by, so then 1 in 1 plus sine of x, that is cos of x in 1 plus sine x.
Good stuff.
Then to find the second derivative, and so that is, so then we have to use quotient rule.
Yes.
Quotient rule again, then so u is cos x, v is 1 plus sine x, and the derivative of u, that is minus sine of x, and the derivative of v is cos of x.
Excellent.
Then it's u, it's v times the derivative of u plus u times the derivative of v divided by v squared, and that is so it's 1 plus sine x times minus sine x plus cos x times by cos x
Great stuff, yeah.
divided by 1 plus sine x.
It should be minus, so remember quotient rule.
Oh yeah.
It's vu prime minus uv prime.
Divided by 1 plus cos, 1 plus sine of x squared.
Good, yeah. All over v squared, 1 plus sine of x all squared. So let's expand and simplify. Probably you might not need to expand the denominator. It's always, a lot of the time it's best to leave the denominator factorised.
Okay, so that's minus sine x, minus sine squared x, minus cos squared x, divided by 1 plus sine x squared, sine of x squared, which is minus sine of x minus 1
But it's good.
1 plus sine of x squared, and then that is just one negative, that is minus 1 plus sine x and 1 plus sine x squared.
Good spot, yeah, well done.
Then x squared, oh, it's not working. So then that is negative 1 and 1 plus sine x.
Good. Yeah, and I don't think you're going to get it any simpler than that. But if we go back to the question, you could ask for it as a function of y, not as a function of x.
Yes, and so 1 plus sine x, that's just e to the power of a y. So then
Well spotted. Good.
that's minus 1 in e to the power of y. And
And now it is a function of y. That's really good. Yeah, I think you probably found the challenge question easier than all the other questions.
Yeah, and that's also the same as negative e to the power of wait, I think it's negative e to the power of negative y. No, I'm not.
Perfect. Well, that brings us to the end of our session. Well done, Cordelia. That was a tough challenge question, but you did it really, really well. Fantastic. I'm very impressed. So well done. I hope viewers enjoyed that session. Make sure what should they do?
So they should like and subscribe. Now,
Brilliant. Drop us a like and subscribe. And if you have any topics that you want us to cover in future sessions, then they can contact us through the website, thedeciphers.org. And until next time, we'll see you soon.